Waterschapshuis. And het Waterschapshuis is the overarching body on IT and data management of the Dutch water authorities. And I will be your moderator during this webinar. But before we begin, I ask you to pay attention to our house rules. Please stay muted, but of course use your mic when you are invited to speak. If you have any questions or thoughts, ask them in the chat anytime, and we will try to answer them straight away. At least my colleagues will do that. Raise your hand when you definitely want to speak. Use the feature of MS Teams. The session is recorded, but feel free to keep your camera on. We like to see your faces, but if you don't want to, just keep the camera off. And of course, be respectful to one another. I welcome you all to this info day of PCP WISE. On behalf of the partners within the PCP WISE consortium, we are with 12 public buyers and 14 supporting organizations, and you see their names, our names and logos on the right of your screen. And in the middle, you see the map, and maybe that's more important because it shows the international character of our consortium, from Finland to Spain to Slovakia and to Greece. And of course, because this project is funded from the for the Horizon Europe Framework Program, the European Commission, I welcome Erwin Agor, especially as he is our project officer. Het Waterschapshuis represents the public buyers, the 12 public buyers in our consortium as lead procurer, and STOA, also a Dutch colleague organization of Het Waterschapshuis, acts as a lead buyer. And of course, I have to mention that Barabes is our project coordinator. And your presence here today at this moment means that you are interested in PCP WISE, probably as potential supplier or as a public buyer, or maybe you are just curious what we have to present on this challenging project. And it is indeed challenging because we want to develop smart, sustainable solutions to improve water management and climate change resilience using space, technology, and environmental data. Today's goal is to give you information about the technical aspects as well on the process of this pre-commercial project. And you can see in the agenda there are two blocks on these two topics. As I said, we appreciate if you have questions, ask them in the chat. My colleagues will try to answer them. And when they can't do that, or if there are too many questions to be answered, we will do that after this meeting. And the questions will be published on our platform and our website. And we need that to create a level playing field with the entities that couldn't attend today. And at the end of this webinar, the third block, you have the opportunity to ask additional questions. And if you want to do so, please use your virtual hand. And we hope that the information will not one direction way. We want also some information from you regarding the feasibility of our ideas. And that will be addressed in the last presentation of Arnoud. And Hans, if you are ready, you can start with the first presentation on the first block. What is the rationality behind PCP WISE? Please start.
Thank you, Joost, for the introduction. My name is Hans van Leeuwen. I'm representing the STOA, which is an applied research organization on behalf of the Dutch water authorities. And we have been conducting the past 10 years a sort of blueprint model for PCP WISE, but then in the Netherlands. It's called the SAT Water Program. And I'm going to explain in this session what the rationale is behind our PCP WISE approach. Next one, please. So we endure climate change in many forms in our daily lives, and the idea is not to fight during the impact of this climate change issues like fires or flooding or extremes on fast or slow onset procedures. It's in our situation that we want to be prepared to those situations. So that's very important to understand. So we're not going to do the flood modeling or flood monitoring, or we're not going to fight wildfires. We are going to set up intelligence to anticipate to those extremes. And we want to be resilient for that. Together with our water managers, city managers, and our nature and agricultural sector managers, we like to anticipate with the right information of our soil, water, vegetation system. I will explain it later, and that's because of a lot of those issues, climate-induced issues, are water-related. And so it's important to understand that we want to build up intelligence for the local actors, the local managers, as I just said, to build up water resilience. Next one. So these are just an idea of the distribution of problems of too dry or too wet. I'm not going into detail, but you can see that over the years in the left picture, drought and precipitation as a result of that, the shortage of that. And you see also that in some parts it's very dry, in some parts it's very wet. But nevertheless, it can also be very dry in the very wet regions. That's you can see on the right-hand side, because along the year, throughout the seasons, you still have a lot of changes also throughout Europe. So you can see that it's not easy to predict from the meteorological part what's happening, but you have to think smarter on the long term on the buffering system of the soil water vegetation system, which is in fact the result of the precipitation, evapotranspiration. So all the factors affecting our soil water system are in the end the basis for our problems. Next one. Yeah, so there is already many research done on European level and global level, of course, and we should use that experience, and we also want to use that. There's a lot of information already present, and therefore we need to be complementary to that. And most of the information is on policy and large-scale level, available on national level, but we need to have acting information on local level. And that means that we also have to have actual and very practical information to reduce the impacts of climate extremes. Next one. So we focused on local acting level. And we need to understand what the pressure of water availability is for the different sectors, as I already mentioned. So it's important that the local shortage of abundance of water in our soils is detected in the right time. So the timeliness is very important, but also it can also induce issues which cannot be prevented most of the time, but we can take measures to reduce the impact and maybe also the frequency of occurring of those events. And of course, there are a lot of related issues. So flooding and wildfires are the most important issues, but you also have indirect issues like water quality. If you have a lack of water and low groundwater levels, it will affect your concentration of solubles in your water system. And also the productivity and etc. Also biodiversity in nature. So it's important to, in combination with the European climate tools, which are available, for example, in Copernicus or in ECWMF or VMO, all kinds of different institutions have generated very important information. Those are boundary conditions for our services, and we can complement our services with that. Next one. So we have to think in a sort of recurrent crisis cycle. So we are mostly triggered by the events and then we act, but we need to prevent and we need to be prepared, and therefore we need to reduce risks. So we are on the left part of this scheme for disaster risk reduction and also be better prepared and to anticipate on the extreme events I just mentioned. And that means that we have to manage our water and our soil water system in the right way, in the right time, and also spatially with each other, between the different management areas and between the countries. So that means that we need to be interoperable in that. I will tell you more about it later. Next one. So in the previous project of Protect, that's the 2 years preparation of our PCP WISE project, many research already has been done on the different challenges in separate ways. And now we are trying to find the overarching link between all those different effects. And that's in fact what I already told you, the soil water vegetation system and also atmosphere linked to that. But it is to understand why all these challenges are occurring and how could we in fact anticipate on that and to prevent the extremes, to improve our water availability and our water distribution. Next one. So why is soil moisture so important? And especially the conditions, those are central. When you have too dry or too wet situations, you can have fast onset crisis, but you also can have slow onset crisis. And the impact of those crises could be very different, and that depends on the way we act as managers and how we anticipate on this, as I already said. And that means that we have to monitor the status of our soil moisture vegetation conditions timely and mostly daily to understand, especially for fast onset, what can happen in the near real time, but also in the near future. On the slow onset, you see effects, for example, of structural drought, and that could induce subsidence or all kinds of problems in your rural area, and also structural agricultural productivity losses or biodiversity losses. So that means that you need to keep track of your soil moisture system. When it's too dry, then you need to take measures to prevent that it's getting too dry, and that sounds very logical, but that requires a lot of management skills to improve that. But you also can take measures, for example, to change your vegetation or your crop strategy in your agriculture. So land use change, for example, and we already see it occurring in Europe that, for example, the wine productivity is getting lower in the south and is increasing towards the middle or to the north of Europe. So these kind of changes also help us to understand to manage our soil water vegetation conditions to reduce the impact of too dry and too wet situations. Next one. And also what we think is important is as well to look at urban as rural. And you can understand that in urban situations, it's much more difficult to model We have to understand what factors affect the water balance, what goes in and what goes out. Evapotranspiration is very important. It's happening by transpiration of the crops or evaporation of open water and bare soils. But when you have a lot of stoniness in your city, you don't have a direct connection with your underground. That means you either have runoff or you have not a contribution to the lower groundwater levels, which has a lot of consequences, either for your green parks, but also for subsidence, for example. It's getting too dry, your foundation is also getting problems. Houses and infrastructures are lowering because of the foundation problems as a result of drought. So it's very important to understand that you need two fundamental different solutions to fight the drought and also too wet situations in urban, but also in rural areas. And in rural areas, you mostly have model-based and data science-based, but especially in the city, it's probably more a data science based application you have to fulfill. It's not easy to model. Next one. Just to go with some pictures and also through Europe. So we have 5 representative regions in Europe. I will come to that later and also after the use cases. But we have, even in North Europe, we have a lot of drought problems. You would say you have a lot of rainfall there, but even then, for example, in the Netherlands, we have 800 wildfires in a year, which is a lot. And it's not always in the news, but it means that that's the water distribution and the water management is especially important because there are structural drought, dry areas and wet areas. And therefore, we need to understand what is locally available in terms of water in the underground. And it can induce a lot of problems like the urban heat island effects, the subsidence already mentioned, but also it can also affect all kinds of green areas in your city area. So you want to monitor that all the time. Next one. And this also accounts for flooding, the other way around. It also means that you need to understand how can infiltration happen to the underground. If there's a lot of stoniness or you have a lot of storage, rooftop storage or other issues that affects the infiltration to the underground. Of course, you need water in the underground, but if it's saturated in the topsoil, then you also have a lot of inundation and flooding with a lot of consequences to infrastructure. Next one. Yeah, as being a land climate in the center of Europe, you have not the moderate influence of the North Sea, for example, or the Mediterranean. So then you have a total different weather system, but also there you have total different impacts, especially drought, but also flooding. But drought is one of the issues we are going to deal with, and therefore water distribution, even also in mountainous area and hilly areas. That's a special challenge we want to tackle together with people in Slovakia, for example, and also in Macedonia. It's more in the south. Next one. Yeah, sorry, I was wrong. This one is more in the south, and the other one was more with the Kalmhoutse Heide in Belgium, the Netherlands, and Slovakia. And here we will have some more detailed later with our buyers, special on those cases. But just to mention what the problems are, I just make some easy to look at pictures here. So this, the rural drought in southern Europe is very important, especially also to agriculture and productivity, but also to biodiversity and forestry. We have a lot of wildfires, we have a lot of agricultural problems there. So it's also important to anticipate on that, also on the seasonality, but also of the structural drought over the years. Next one. So what we did in the past 5 months, we started at the 1st of January with PCP WISE, is especially have a lot of interaction with our buyer and user community. We had about 15 to 20 different use cases with our problems, and we have funneled them together with our buyer and user community inside the consortium and outside the consortium to understand what is the representative selection in Europe, but also in terms of problems. And we funneled that, and we came to 5 representative groups, and we will have more in detail the illustration of those groups by our users after my talk. Next one. Because together with each other, we have been working on what are the functional needs and requirements. As a result of those problems, we categorize them in mainly 3 groups per urban and per rural issues. So we have the day-to-day regular management that needs to be supported with the intelligence I just mentioned, and also for the different managers in the sectors. Of course, when you have extremes, then it's important to understand if the soil moisture conditions are too dry or too wet, what kind of risks per sector can that induce, and how can we try to make indicators of that? How can we find out where are the priorities in space and in time to tackle those issues? And of course, the climate part is also very important. The climate on long term is for hindsight in decades, but also for scenarios in the future. So regular crisis and climate processes are supported in our PCP WISE project. So those are the 5 groups, and I'm not going into much detail. That is done by my colleagues, buyer partners. So I give them the floor now. Thank you.
Thank you, Hans, for your presentation. And indeed, the group leaders of the 5 use cases are going to inform you more in detail about their needs of the public buyers, and they will present their use case. And we start with Meri Vainio from Forum Virum Helsinki, our Finnish colleagues.
Thank you, Joost. Can you hear me? Yes.
Yeah.
Yes. So my name is Meri Vainio, coming from Forum Virum Helsinki, which is an innovation company owned by the city of Helsinki and representing public buyer here. We are from Finland, and together with Rotterdam and Haarlem with this urban road use case. And change the slide. So the challenge is urban road so for example, road impacting on soil moisture, groundwater levels, and urban infrastructure. And here are some of the challenges that road leads to subsidence and creating like heat island effects and creating challenges with the old housing and limited green space. Next slide, please. So why we are interested in this? Well, we have a lot of reasons to monitor and maintain the sufficient groundwater heights. The subsidence is one thing, but also like old historical buildings are on wooden piles. And we have a lot of like sulfide clay areas, for example, in Helsinki, where there is a risk of the environment to get emissions from the sulfide. Also, stormwater management. Drought is not only caused by the heat, but also our human impact, where we manage the stormwater. We direct it out of the city, and we don't get so much infiltration happening in the ground, and the groundwater level is in the risk of getting lower. Currently, for example, in Helsinki, most water management activities are oriented around monitoring. So we have scenarios and simulations, our modeling to support the urban development. but we would like to have better understanding of the combination of stormwater and groundwater. Next slide, please. So these are the test sites. So we are going to provide a test site from Helsinki that is going to be around Longinoja Creek. That is a former airport area where we have a lot of redevelopment going on at the moment, but also some natural creek area that are protected to be considered. And there is also a possibility to test in Rotterdam, Netherlands, and the test site will be defined later. Please.
Next one.
Yeah. So what we are currently. Thank you. So we have currently a lot of data available from this area, from groundwater levels to meteorological statistics and land cover data, also stormwater modeling. So what we would like to have is the kind of like more thorough understanding of and combination of the data in future. Next, please. Some user case examples. So we have like need for more detailed information, for more detailed urban planning as an urban water management planner who has to identify and address the groundwater related issues in urban planning and construction projects, but also in a bigger picture, more scenario working in adaptation scenario for work in respect to climate risk to support the decision making in bigger picture. So this is the case in short. I don't know if we have time for questions now or later.
We will do it later in the last block, and you can ask your questions, of course, in the chat. Then the next one, this group number 2, use case 2, urban flood Northern Central Europe, and this presented by Martin Tucina. Martin, the floor is yours.
Thanks a lot, Joost, and good morning to everybody. First of all, apologies for the noise behind us, actually, as I'm traveling, so I'll try to be fast. And with that, I would really like to present the use case 2 within the sort of overview you can see. And if we go further on, yeah, the main, let's say, motivation, as already was somehow indicated by Hans' introduction, was to focus on the floods challenges in the rural area. And with that, we already, after this first iteration with the partners in the cluster, came to some sort of scoping of the use case towards the inland waters and water related to the seasides, especially for the effects of the floods you can see related with the rising water level, with the seepage and the sea level rise. And we are aware about the impact of the climate change movement, and we also would like to use this use case to better demonstrate what the climate change is actually causing to those regions covered by this use case. And we are aware that such hazards are creating significant impacts from the infrastructure towards even the losses of the life, and we would really like to make sure that we will manage to use this public procurement process to improve the situation in the target areas. So if we can go further on. Okay, so what's the main motivation, and please click one more time, is the fact that this use case is covering the the 4 countries in principle. So you can see it goes from the north in Finland through the Denmark, Germany, and ending in Slovakia. And particularly Bratislava as a capital city will be the test site for this use case. And here we have already some experience with the floods, especially connected to the Danube region. And if we can go further on, in Bratislava, yes, we experienced the significant impacts of the floods, as the flash ones, as well those which had took a bit more time. And there are already involved the buyers from the consortium, namely Slovak Environmental Agency and the Minister of Interior, who had direct interaction with the impacts of those floods. And if we can go further on, I would like to really shortly share you. Yeah, we can move on. We will come to this topic. You might have heard that Danube is a very wild river, and on this picture we just wanted to share with you some indication from, let's say, timeline perspective, that floods are nothing new, especially in the Bratislava. There were already some serious in the past, and we would really like to utilize this PCP WISE project to get some better view towards the future. So yeah, if we can go further on. Now I would like to ask Jost to slowly go through the next 4 slides, which are example which showed what happened in the fall last year, when there was a significant flood in Bratislava, and we were trying to use the services provided by the Copernicus Emergency Management Service. And here, slowly, if you go further on, you see how the water was rising in the area. But this was a really sort of reaction after the flood. But we were really happy to be able to get access to some data shared by the European Commission. And with the help of the project, we would really like to get the possibility to react not after the event, but even be more prepared before the event. Yeah, we can go on. So what is this use case about? Here you can see the structure of the sort of sub-consortium. There are 4 partners involved. Aside of agency, there is a climatorium, Forum Birium Helsinki, and EHV from Germany. And our main target stakeholders are, I would say, threefold: public sector, business, and the citizens. And if we can go further on. Yeah, these last 2 slides are the most important, I would say. First of all, we think that we would really like to ensure that those offers which will come through this procurement will cover we call them functional and non-functional requirements. In principle, we are really interested in the data as a content. We would like to have the data which are mainly related to the topics already mentioned, like Stallmeister, the data related to the rainfall, to the evapotranspirations, and other type of data sets, which I'm sure will come to the closer specification a bit later on. But what we would really appreciate would be the timeline series, because these also help us to see the maturation of the phenomena across the time. We also have some system requirements. We would really like to see supported both type of interfaces for machines and for humans. And if you can go further on, there will be also so-called non-functional requirements, which for those involved in the ICT development might be a bit more familiar. So there are some expectations towards the architecture. We would really like to have some experience related to user-customer experience. And of course, these aspects for security and reliability is something what we really count on. And if we go for the last point, which we would like to share on this first interaction. Yeah, and one more click. So what we really look for is the solution which will allow us and partners to get access to the data. And we would like to have the interfaces which will help those involved in the management of those aspects to have practical and understandable interface and interaction with those data, to be able to create some analytics and communicate the data to the target audience, and to be able to achieve those benefits you can see. And if you click one more time, to be able to really address those benefits by the end of the project. So if there will be any questions, happy to answer them either now or later on during the communication through the platform or any other type of communication channels. Thanks a lot.
Thank you, Martin, for your presentation on your use case. We're now going on with use case number 3. The rural drought in Northwest Central Europe, and I to Klaas Poli from Benego, de Kalmhoutse Heide in Belgium and in Holland.
Thank you, Joost. Good morning, all. Well, that's strange. I'm looking at the same presentation and I see the slides. I don't know. There's maybe synchronization.
Klaas, then I stop sharing. Will you share your screen?
Sure. Okay. Thank you.
Sorry. Yeah.
Does that work for you? Can you see my presentation full screen?
Yeah. Yeah.
Okay, thank you. So indeed, yeah, I'm from Grenspark Kalmhoutse Heide. It's a Dutch name, but it means the border park of the heathland surrounding the town of Kalmthout in Belgium. It's a border park. It consists of 60 square kilometers of nature reserve situated across the border in Belgium and the Netherlands, and it's most famous for its heathland. And it's also a national park on the Dutch side. It is actually a sanctuary, both for recreation and for nature, because it is surrounded by intense agriculture, suburban and residential living areas, towns, and there's also an important influence of industry and big infrastructure towards the city and port of Antwerp and other cities like Breda in the Netherlands. Now, our organization, we've actually just reformed into a public utility foundation based on a cross-border governance model. And within our organization are deeply embedded a representation of all the stakeholders in our area. These are terrain managing organizations such as Natuurpunt, ANB, Staatsbosbeheer, Natuurmonumenten, etc. So the organizations that actually manage the nature reserve terrains. But we also have a representation of terrain owners such as municipalities, private landowners, other companies doing terrain management for private landowners as well. There are also drinking water extraction companies active in our area. We have also a representation of agriculture and forestry activities. Provinces are represented in our organization, as well as environmental agencies. With a small park office, we focus on projects that require coordination between all of these actors. So each of these actors can have their own small projects, but as soon as a project requires coordination between different entities, they come to us and we implement projects for these entities and supervise everything. So I already said that the border park itself, the core area of the nature reserve is 60 square kilometers, but we actually have a management plan, a master plan for the coming decades that looks much further and encompasses an area of more than 100 square kilometers. Mind you, these are all Nature 2000 areas, But of course, like I said earlier, within our governance model, we are deeply in contact with surrounding organizations and authorities. Yeah, next slide, please.
You can do it.
Yeah, so of course. Sorry, I'm a bit confused. So we will focus on rural drought challenges. So what we have, our area is in fact an infiltration area. Our core nature reserve area is not fed by rivers, so we are purely rain fed, and apart from the rain, we only have water going out of our area. And in recent years, we've all seen these blocked weather patterns with prolonged periods of drought, and then other months or years almost with intense rainfall. So it's not so much that we have a structural water deficit across years. It's just that the distribution has become very uneven and hard to predict and hard to act on. The entire region is historically just not prepared to act on this new situation. Just as and this of course increases risks immensely. For instance, last year was very wet. We have had an explosion of purple moorgrass. It then dries in the winter. Now we have a record drought season, which means that there is a lot of fire fuel present, and we're seeing throughout many similar areas that there is a record number of wildfires active in our region now. We've also had a minor fire in our area this year, but very similar fires have occurred 4 years ago and 14 years ago. And so we need new tools to deal with this new highly variable situation. But we need to better inform decisions for water management, also at a very high resolution. We need to understand much better where we can retain water, when we can retain water, how we can increase water buffering capacity, and so on. So here is a map depicting our organization's master plan area, delineated in blue. So yeah, these are sandy areas where water infiltration occurs, and they are very much surrounded by agriculture, residential areas, etc. There's also a stethoscope reference measurement site present in our area, which is interesting because when we look at the data that we already have present, we have many. This is just a selection of data, ancillary data that are available that can serve to develop the solutions that we are looking for. There's just a small selection. Many more sources are available, but we have, for instance, many in situ measurements from Flanders databases. There are sub-data 3.0 products, and importantly, a stethoscope reference site is present in our area. So we are targeting all of these organizations represented in our governance model as end users. Here is an example of just terrain managing organizations, what they lack, what they currently lack. Terrain managing organizations typically have a lack of data-driven management decisions, and they need high resolution information, or very high resolution information that is dynamically updated. There is an eco-hydrological model for our area, but it performs quite poorly in many sub-areas due to the very difficult characterization of the underground. And so we also need to rely a lot more on empirical data and ad hoc decisions for water management. And this is why it's actually essential now for us to develop dashboards that represent water situation and potential decisions that can be based on it. But we are not only looking into the terrain managing organizations. We also want to support agricultural producers surrounding our nature reserve that face irrigation and water buffering decisions, drinking water extraction companies, municipalities, and so on. Okay, that was it for me. Thanks.
Thank you, Klaas, for your presentation and the overview of what's in your site. Thank you. Then we go to the next use case, and I will share my screen again. And that's the rural drought and flooding in southern of Europe. And that will be presented by Estefania Blanche from the Institute of Space Studies of Catalonia. The floor is yours.
Okay, thank you very much, Jost. Good morning to everybody. Yeah, next slide, thank you. Yeah, I'm Estefania Blanch, Earth Observation Project Manager at the Institute of Space Studies of Catalonia. And here what we want to present is a tandem of two institutions that will lead this use case which will be in the south of Europe, because we have similar effects and needs in the different places that we will perform this use case. It will be in Catalonia and the region of Central Macedonia in Greece. And just to explain a little bit, the Cartographic and Geological Institute of Catalonia will act as the public buyer. And it's an institution that has the competence for geodesy and cartography for Catalonia, and also competence for the survey information about the soil and subsoil. And they will provide data from Catalonia, from these soil moisture stations that they have, and also these maps for different soil types. And we in the Institute of Space Studies of Catalonia, we will act as a supporting institution. We have an area of the promotion of the Catalan space sector, and then we see that this tandem for this use case, it can be interesting. Then next slide, please. Okay, this is a use case to deal with the rural drought and flood challenge that we have in the south of Europe, in the Mediterranean basin. And the test site will be in Catalonia, and this in the region of Central Macedonia. In Catalonia, we'll be more focused on drought. And we want to also test in this use case, the use case for floods. Because we have this in the Mediterranean basin, we have these two challenge. We have had drought periods, long periods of drought in Catalonia, as you could see before that Hans presented, and it has a great impact in the agricultural production. And now we want to try to have some tools to prevent this situation and to minimize the economic losses that we had during these years. Also, the reduced soil moisture and forest degradation accelerates also wildfires. If we have these long periods of drought, we also have a large amount of wildfires that also we want to deal with this and to try to have these risk maps at a higher resolution that we have now, which is very important. And also this extreme rainfall that provokes these floods in the rural areas and also in some urban areas. That it's also we need these risk maps of high resolutions to prevent the situations and to aware the population, and also to try to minimize also the lost production in the agriculture. Okay, next slide, please. The test site, it will be in Catalonia. In Catalonia, we have different irrigated areas. One is irrigated, and some areas are rain-fed irrigated. And we have different areas. We have the Catalan River basin, and the test site will be in Girona, in the northeast of Catalonia. That river basin is serving the 92% of the population. Then we need to know better how to manage this water for population and for agriculture. And the other test site will be in Lleida, which is the Catalan Ebro basin. And also we will see in that area, which there is mainly of the fields are rain-fed. Then we need also how to deal with the drought episode. And also we want to test similar results in the region of Central Macedonia in Greece, and also to test the effects of floods and the two wet situations in this region. Next slide. Okay, the data that we will provide will be the in-situ soil moisture for a network of in-situ data that we have all around Catalonia. It gives temperature and soil moisture at 4 different depths, because it's important for us to have the soil moisture at surface, but also at the root zone to know how the agricultural production will be affected. This data, this station also gives some information about the air temperature and humidity and precipitation. It takes data every 30 minutes, and there is a long time series that can be used. We will also provide with geospatial information about the soil maps and land cover maps, and of course meteorological data that can be used for the prediction of weather. I didn't have added here, but it's also that we also can provide some data from satellite from Catalonia that they give a resolution for 5 meters for the region of Catalonia that can be also provided here and can be interesting to use. Next slide, please. Okay. Here's users that, as an example, we have. We want to explain an example of user of this product that can be the environmental and agricultural government agencies, that they need to know how this drought episode impact on the crop production, and then they need to anticipate in these effects on the agricultural production to manage better the water for irrigation. Then the pain points that they have now or less is that there is a lack of timely and high resolution surface and root zone soil moisture, and also for evapotranspiration data. This is very important, this data, and it's important to have high resolution because we need to take decisions at a local region, which means that we need for soil moisture resolution, we need a resolution better than 100 meters, for instance, because we need these field area resolutions that we need to see. Also, a pain point is that the crop field declaration is done only once per year. This is not. It needs to be improved, but it has to be by our side. And also, which is difficult, is to estimate this drought impact on the agricultural production, and also it's important for the forest health, to know the forest health, because then we can have some wildfires also. The benefits for this solution that we are looking for is mostly to have this early anticipation of drought effects in this case, but also for flood effects. It's very important, this early anticipation, to minimize the economic losses. Then, which is needed is these risk maps that can be very helpful to see which areas needs more attention than others. And this will support the water allocation decision for the administration. And of course, it's important to reduce these economic losses that we have had during these past years due to these droughts in Catalonia. Which also what we need is this user-friendly tool that will help for planning and impact assessment.
Sorry.
For yeah.
Sorry.
Okay, don't worry. It's just the previous.
Oh yeah, yeah.
No, one. Yeah, one. Okay, previous one. Okay, thank you. Yeah, it's just what we need is this user-friendly tool to help to assess these decisions, and also it will support the design and implementation also for new scenarios such as change the crop typology, and it will help for future views. Other users that we have not put all of them here as an example, but can be for drought, can be agricultural producers, water management authorities, environmental and agricultural government agencies, insurance agencies, for instance, and for floods can be water and shipping management authorities, local authorities, civil protection agencies, local water management authorities. And well, this is the overview of this use case relating this to wet and to dry at the same region of Europe. Thank you.
Thank you, Estefania, for your excellent presentation, and sorry for going too quickly. Then we go to the next presentation, and that's about use case number 5, and we thought it would be presented by Pernille Weiland from Climatorium in Denmark, but she sent us an email this morning that she is ill, and Hans van Leeuwen is taken over for her. So Hans, the floor is yours.
Yeah, thank you. This is the use case 5 of Northern Europe, and that's about mainly drought, but also wet situations. Climatorium is a research entity, but is a very applied research entity. They are working closely together to the utility sector. And in the north of Denmark, you have all kinds of problems with subsidence, but also rising of the topsoil due to water pressure from the surrounding seas and seepage and so on. They have a living lab, about 500 square kilometers, where they do research on those effects of rising and subsiding. Why the utility sector? Because the utility sector is investing in managing the water systems, but also do that because of their different infrastructure on electricity, water supply, and all kinds of infrastructure underground, which has problems with those dynamics of rising and subsidence. So all those investments need to be safeguarded, and that's why a lot of research is needed to keep the situation more stable. Important is climate adaptation in general and how to deal with it. From that perspective, it's important to work together with other partners. In this case, in the Netherlands, we have similar issues in the center of the Netherlands, but also in the peat areas where we have similar issues with dynamics of the top surface due to subsidence, but also rise. It's a seasonality with hysteresis, so you have up and down situations, sometimes 30 centimeters, and even in Denmark, I understand it could be even sub-meters. So that is important also to use the experience of the Dutch in this one. And together with the Germans, we also have peat experience, underground peat experience, and that is more affecting from the drought perspective. You could also have peat fires and underground fires. We have the same as in the Netherlands. So all this experience is grouped in this group 5. Next one. So this drought impact on soil moisture of the subsurface and also the impact on groundwater levels and land levels, that's one of the main issues here as well in rural as also in urban, and those are more smaller communities, not big cities. Inside, for example, this living lab or in this peat area in the Netherlands, for example. You also have clay and other sediments, but clay is also important in terms of compaction and could be also having structural problems on the long term if it's irreversible compacted. And for the other issues, it's important to safeguard the infrastructure of the utility sector, but also the water quality. So the wastewater issues there is also a very important one. So it's important to have a good vision on water quantity with its effect on water quality. And these relations are researched there as well. So the Lemweg area is for us the main test site to study this and also the impact to agriculture and local communities in the utility infrastructure and the impact on peat fires. Yeah, next one. So this is this living lab in the north of Denmark. On the right-hand side, it's too much information, but what is nice to know is there are many different stakeholders here, not only on the long term in terms of management, so the infrastructure management, but also the agriculture and the local city management, but also the different stakeholders on climate policies. So it's important to have a long-term vision on this because those investments to safeguard the utility sector requires decadal insights for the next 50 years. And therefore it's important to base the research on good information on trends, so hindsights, but also forecasts. And to understand this system, a local soil water conditions monitoring is very important for them. Next one. It's more on the data. I'm not going into details, but there is a lot of data which will be also available from the field level, but also from different national and regional databases. And it's important to understand that part of this will be, of course, used by the consortia who will set up solutions for this group, but also for the internal validation of our own team to evaluate the different solutions coming in. So it's important that we have very well insight in the hydrology and also in the different factors affecting the soil water system. Next one. So as I already said, the example user here is the utility sector. So their infrastructure is important, of course, and therefore also the different issues with the drinking water facilities, for example. So it's important also that wastewater and water quality is safeguarded, and that's closely related to this whole system there. Also, it's important that to find out that the pain points is especially the investment part of the networks and the maintenance of that. And due to the dynamics of this subsidence and this rising of this land surface, it's important to understand if those financial expenditures are safeguarded and that it's not endangered by different impacts of climate in the long term. So Climatorium hopes to get the WISE information to have stronger decision making and better support for justification of investments, but also to have a better safeguarded pipeline system and network which endure and which also can anticipate on subsidence mechanisms and also to rising mechanisms. And of course, that all increases a better security for the use of the infrastructure system, and also to anticipate on risks and to deal with those risks with the right measures based on this soil water intelligence we hope to build from WISE. Next one. And it is already the end.
Yes, thank you, Hans, from taking over from Pernille. And I want to say that if you have questions, please ask them in the chat. This is the chance to get your answers you need. We are a little bit behind schedule, but that doesn't matter, I think. But Hans, go on, and please don't take too much time.
Yeah, so I will be...
Sorry for that.
No, that's all right. I can condense it. So this part is more on how can we use the WISE experience from the use case level to a more generic approach on European level in the future. And what does it require in terms of preparation of anticipating on this scaling? That's the reason why we at first distributed the different lead test sites all over Europe. In the red stars on the left, and you see the green stars with the supporting partners and test sites, where we also have additional data and additional experience built up to support those red test sites. On the right-hand side, you see also little round dots, and those are our benchmark dots from the STEMIS scope model, which is a twinning model of energy balance, crop modeling, hydrology, and also atmospheric interference with the crop soil system. And that's a physical-based system, which is a benchmark for the solutions coming in. They calibrated and validated this system on those 64 points in Europe. And as Klaas Pauli from the conference I had already mentioned, one of those points are also inside his test site or in other test sites closely to our test sites, so it will help us to understand. Of course, it's point level. We need to extrapolate it to plane and spatial level. So that's the reason why we also have remote sensing and other spatial data sets, either from Copernicus or existing data sets, to improve our insights there. Next one. So as I already mentioned in the previous presentation, we have from the functional requirements, from the needs of the buyers, we have categorized the regular, the crisis, and the climate information and functionality of this information, which is needed to support the buyers and the user community behind the buyers. By the way, we are going to validate those needs in June with the user communities behind those use cases you just have been presented. And that also will help us to further focus to the real needs. So just this picture again, just to say we have day-to-day information needs, we have risk assessment as input to crisis needs. So we are not going to model floods. We are not going into the existing systems of fighting fires and so on. No, we are anticipating to that. And therefore we can feed into existing systems. And the urban climate situation, and also the rural climate situation, that is something which is important to link up with, to have a hindsight, and from there on also have a basis for scenario forecasting, which already is in place in terms of meteorology, but also in terms of modeling. But we need to adapt it with our WISE actual local system and information we have. Next one. Just to understand that those three elements, so the blue is the regular day-to-day water management or asset management or city management, and you have there different people with different capacities and different information requirements. Then for example, in a near real-time crisis situation where you need timely information and totally different acting, and also which is totally different on the long term of making plans on climate adaptation and mitigations, which is on decadal timelines. So sometimes the people are the same. So you have the same civil servants working in day-to-day and in climate policy or in crisis management. And once you have a transition from one situation to another, from regular to crisis, for example, then either people have to change, and certainly they have to adapt to the new information to be ready for the new to adapt to the crisis in this case. So it's important to understand that information can have different functions, for different roles and different organizations and stakeholders, and therefore it's important that we have the right basis in that to start with, and then later try to adapt it as much as possible to the different stakeholders. Next one. So from the functional requirements, we came to information requirements and starting to get a bit more technical. Hydrology is very important. So that means, of course, there is already a lot of modeling in place, and that's also why we want to link up with this modeling. We need hydrology experience in the consortia to solve those issues, because the main requirement is to have an actual insight in the soil water and groundwater conditions. And linked to those different groups, we specified a bit more what the information technical specs are. So short-term forecast in terms based on the short-term forecast from the meteorology, but then in this case on the soil moisture content related to that, and also specific apps and applications on subsidence remote sensing based could help to improve the situation awareness of and also the soil water condition insights. So I can work this out for every mode. I will not do that because that takes too much time. But it's important to understand that those requirements lead to technical specs, and I come to that later. Next one. So it's important that it's really a basis for user support to act. So we need to have actual local insights. And we already had a question, for example, from Hazel Winsemis in the chat. We already have flood forecasting systems, and we already have all kinds of models. Yes, we know. We also know that there's a lot of Copernicus. We have the EFA system on river, watershed in Europe, and also early warning systems. What we are going to focus on is on the input to those systems, which is mostly an estimation. For example, infiltration of topsoil that requires actual insight of this hydraulic connectivity and systems, physical systems of your soil water systems. And mostly I also experienced that in Interreg projects like the flash flood breaker. This is something which is an estimation and is not a real monitor of the local, in this case, 100 by 100 meter situation of the subsoil and also the local groundwater. So that means that you need to adapt to local situations to be better informed. And that's what we want to focus on, and also to be interoperable with. So everybody has his own models. We want to get a standard so that everybody can communicate with each other in the same way, and therefore also exchange information and be prepared together inside the same watershed, but between different management regions or country borders. So cross-border interoperability is important. And therefore, it's important also to have this day-to-day system, because we know that the soil water system is a buffer, so that will react slow on the impacts of evapotranspiration and rainfall, but that depends also on the type of soil. So with clay, you have different buffer systems than with sand. So that's important also to understand how that will affect the local situation on the dryness and on the wetness of those profiles. So you have fast onset, but also slow onset issues. So it's important also to, and that's what we are going to ask also to the different consortia, is to look back for 20 or 30 years, use the information from this time to understand what the trends are. And of course, climate change is dynamic, so everything calculated from the past is not a guarantee for the future, they say. And that also accounts for climate change. So it's a start of insights, and of course that could help us understand to better forecast on the long term for climate scenarios. We will do it for all 5 groups. So we require solutions for all 5 groups. We know that's a lot, but it's all broke down. It's all based on this soil water condition systems. And that means that we also have to focus on that. So 90% of the solution will be the regular monitor of the soil water systems and the groundwater systems and the limits of those systems per sector. And those are the risk indicators, and all on daily basis. Next one. We work with 2 scales. We work on the test site scale for each lead group, and we also will work on the watershed level. And on the test site, we will have a bit more detailed scale, certainly in city areas, and for the rural area, we will also in hydrological terms, we will have a high resolution 100 by 100 meter resolution, which is detailed for enough for a hydrologist, mostly on management level. We don't need the pixel resolution, but we need the management area resolution for the managers to act. And that's in city areas, it's larger than in rural areas. But we have 2 scales for every site, so that we also can validate the results with the detailed measurements on the local site and set up a right basis for the rural surroundings. Next one. This is more in detail. You can read it also later, but this is in short the spatial and the temporal requirements technically. Locally it will be more on the test site level and higher detail, and in the surrounding area on larger detail. And in temporal scale, we also have the daily, and in historical and future, we have the deep information. That's the presentation. Yeah, next one. So I also already mentioned it, the interoperability is very important, and especially to start with. So we also need to understand what could be a standard way of operating. In the Copernicus, they already have a lot of data sets as input to our integrated solutions on the soil, water, vegetation conditions monitor. We intend to task here, but we need to bring it together. And that's why we use an interoperable and also industrial standard model ModFlow to have a sort of representation of each solution. The consortia are free to calculate with their own models, with their own systems, but in the end, the output should be reparameterized into the ModFlow conditions so that we can compare it and also can validate it and also can have a unique interoperable way of working with it. Next one. So this is a complex scheme, but just to give you the added value of WISE to existing systems. So on the right-hand side, we have the existing EFAS system, which is, of course, an existing and very well early warning system on river basin level. It's very important. That can help us to actualize also on local level on the land surface and not only on the discharge, but especially on the land surface conditions of the soil water systems. And of course, we have going to the left the local models of the hydrologists of the different users. So the water authorities have their own hydrology models and their own cultures. They are used to that, so we have to keep that and respect that. But of course, we need to learn to talk to each other. So we need an intermediate model, and that's the ModFlow model in this case. And from the market side on the left, on the top left, the solutions then also will be then incorporated in this ModFlow operation environment and make a base for the interoperability, not only between the users, but also to the team for validation and also with this benchmark model standard scope from the UT20. In this case, to also to calibrate and validate it with the local test site information from each group. And of course, you have also nice presentation possibilities and also functionality in the iMod suite on top of this ModFlow situation, so that we can create presentations or even sort of simple dashboards on spatial and temporal sense. And also integration with local models and field information and knowledge from the local user. And this is something which also needs to be taken in regard. Next one. So not to go into detail, but there are all kind of publications, but also the ModFlow, I just mentioned it, is open source. Yeah, why ModFlow? We know there are many other models, but we have to choose one. And on this operational level, we need a system. So Europe is just starting with this hydrology strategy. ESA has been starting with the hydrology strategy. In Copernicus, you have the EU Hydro roadmap program. It started 1.5, 2 years ago. So we just make a step. We use at this moment for the coming 3 years the ModFlow, but it might be that it evolves to another system. It's more about the interoperability and how to come to that. And so we're not going to have a technical discussion on this. It's just functional for us to use this. Next one. Next one. This is just more information. So the functions I already mentioned. So interoperable, representing the solutions from different sources, from different consortia into a unique environment and comparable environment, and therefore also a presentation tool and to exchange also within the project. Next one. So because it's open source, because it's practical, it helps us to enable to exchange our experience, and in the end also we will have an help desk function inside the project if there are questions from either the consortia, but you need a hydrology expert inside your consortium to deal with these integrated solutions. So mostly hydrologists are very familiar with ModFlow, but it's more on the user side, how to receive the information and how to link up to their dashboards and link up to their systems to exchange and also disclose the solutions to their user environment. Next one. So those are the basis of WISE. We need a regular day-to-day monitoring soil water vegetation conditions system. And that's the basis is 90% of the solution. We need it on TRL 8 level. That means that it's nearly operational, embedded into the user environment. And that means that also that it needs to be professional and also to be tested. And we will do it in phase 2 and also demonstration in phase 3. And also calibrated and validated with the local information on the functioning of it. And the second part of the basis is the regular risk assessments as anticipation to the extreme situations as a result of too dry or too wet situations per sector. That means that we have to dedicate for agriculture or for nature or for city environments in different ways, because too dry is different for agriculture than for a city area or for each different functioning water management or governing system. So this is important to dedicate it there. And the next 10% can also give extra points in the ranking if we have additional sector-related and also specific user-related issues which are common enough. That's the reason why we have the validation of the WISE direction of solutions next June with all the user communities to find out if they agree with the different applications. For example, is it interesting enough to have a heat stress or heat island indicator or subsidence indicator as a result of the soil water problems in the underground? And of part of that, it's important that we have general output in the TRL 8 fashion. We also need to scale up later after 3 years with the different member states, that they have mechanisms to procure themselves, that they have input and experience from our 3-year evolution of this project of WISE, to understand what they could ask the market for solutions for their climate-related problems. And this blueprint will help us, but also will help the users, but also especially the buyers to procure this. And of course, we need this cross-border cooperation model, especially on river basin level, between the different managers, and therefore it's also important that we have standardized solutions. Next one. So for all 5 groups, we ask, with the different problems, we ask different solutions, but based on the 90% solution I just mentioned. And it's also important that you have a multidisciplinary team to set up this integrated approach. I will come to that later with the last sheet. Especially for rural and urban issues, those are fundamentally different behavior of soil water systems. So it's important also that the solutions will be dedicated to that. And as I said, of this is related to the monitoring and the risk assessment, and 10% more on specific issues. And a central issue already at the start is the quality assessment and the quality evaluation, but also the standardization and interoperability. And one thing I repeat all the time, we have already a lot. We have to use it either as boundary conditions or as prior knowledge to our local dedicated solutions for local acting. And that needs to be TRL8 operational. Next one. We have an infographic just to mention that it's a sort of summary what has been told just in the past presentations. It's too much detail, but the central message is here that we have challenges, and those challenges have impacts. And with PCP WISE, we want to tackle those impacts. We want to anticipate, and we also want to reduce those impacts and help the local manager. Next one. So, okay, I had one slide included, but it's not inside here. That was more about the formation of your consortium. So you need a hydrologist, you need a sort of civil engineer party, you need a main contractor who is able to invest and scale up in the end. So to start with such a partner is important, not only to lead the consortium, but also to have a sort of solution architect who bring different disciplines together. And also remote sensing specialists are important, of course, because they are part of the solution. They are not the main solution, it's a part. So we need to think in an integrated way. So therefore, we also need a multidisciplinary team. And that was my presentation. Thank you.
Thank you, Hans, for your presentations from the beginning to the end in this block. It is the technical information, and I see already some questions in the chat. And the most recent questions are about the use of Modflow. So we will have, I think, a discussion on that. Then we go to the second block, the PCP WISE process, and I invite Ana Lucia Jaramillo-Villasis, bloody hell, to take the floor, please.
Thank you very much, Joost. Good morning to all of you, and thanks for the clear presentations on the challenges and the use cases. And to tackle these challenges, to achieve solutions for these needs, we have deemed important to use the innovation procurement instruments. And innovation procurement takes place when the public buyers are acquiring the development or the deployment of innovative solutions, pioneering innovative solutions to address these mid to long-term public sector needs. And here you see the graphic of pre-commercial procurement. That is the tool, the procurement approach that we will follow for PCP WISE, and the public procurement of innovative solutions. That will be the follow-up procedure to purchase the solutions. But we're focusing now on the R&D services. This is why pre-commercial procurement means before the solutions are commercial. And in this cycle of innovation, we have several phases. Phase 0, that is the phase in which we are now, like defining our needs, looking for the state of the art, but having this engagement with the market. And in phase 1, we will look at the solution design, the phase 2, the prototype development, and the phase 3, the testing of the services, the products. This is a competitive procedure, so several suppliers can participate so that we can compare the offers throughout the phases. Here you see also the technology readiness levels corresponding to each of the phases of the pre-commercial procurement. So we start at TRL 3 with the phase 1, and we aim to go up to TRL 8, as Hans has explained, passing through the prototype design and going to the testing in the different test sites. If we go to the next slide, I will give you some background on the legal framework for pre-commercial procurement. That is a tool, a procurement tool that falls outside the scope of the European Public Procurement Directives, which give us some more flexibility in order to do that. And specifically in this procedure, not all the benefits are accrued exclusively to the contracting authority. And that is because the technology providers are going to keep the intellectual property rights of the solutions they develop so that they can exploit it later. And the public buyers, of course, have access to these solutions and also to the rights of use through licenses, for example. In this procedure, the rules and the principles of the Treaty on the Functioning of the European Union are applicable. So transparency, equal treatment, non-discrimination, the competition, and we are regulated also by the communication from the Commission on pre-commercial procurement that describes the features of pre-commercial procurement. Of course, also the Commission staff working document and the framework for state aid are relevant in the sense that there's no state aid in PCP, and as long as the conditions are fulfilled. If you go to the next slide, we'll see that pre-commercial procurement has some main features. It is characterized by the competitive development in phases with different suppliers to get the best value and the best solutions by comparison. It's a risk-benefit sharing under market conditions setup. That means, as I mentioned, that the procurer, the public buyers, do not pay the full cost of the R&D because they are not paying for the IPR. The IPR remain vested in the suppliers, in the technology providers, and there's a clear separation between the procurement of the R&D services from the actual deployment of the commercial volumes of end products. So we will focus on PCP on the R&D cycle, as you can see in the image on the left side, on the TRL 3 up to 8. If we go to the next slide, we will look into the PCP WISE process. So this is the different moments in the PCP project, PCP WISE project. We have the preparatory phase, in which we're now, phase 0. We're developing these use cases that you have seen and also conducting open market consultations. We launched the procedure by September, and the tendering phase is deemed to be taking place from September until February 2026. And the actual implementation of the PCP project, those are the phases, ran from March 2026 until December 2027. This is how we have foreseen initially the setup of the phases. And in the open market consultation document that describes these phases and the envisioned outcomes from these phases, well, you can also comment through the request for information questionnaire if you have any comments regarding the phases or you have any questions on this. If we move to the next slide, this is some information that you will find in the open market consultation document. this document is published on the website of PCP WISE, but also the Amica platform. And you will find this table. In this table, you see the PCP phase. There are 3 phases, the number of contractors that we envision for each phase, the duration of each phase, and the maximum budget per contractor per phase, and the total budget per phase, and the total budget for the whole 3 phases. So as you can see, in the phase 1, it is expected or desired that we have 5 contractors or 5 consortia, and that this phase that is concerning the solution design, that is the solution design on paper, let's say that the duration will be 4 months with a maximum budget per contractor of 300,000 for a total budget of 1,500,000 for the whole phase. Phase 2 is expected to durate or to have a duration of 11 months with 3 contractors competing as well. The budget per contractor in this phase is 2,400,000 for a total budget of 7,200,000. And for phase 3, we expect to have at least 2 solutions that could be tested. And the time frame to do that is 6 months, and the budget allocated per contractor for this PCP phase 3 is 1,500,032. Well, you can see these ciphers in the table. You can look also into the Open Market Consultation for more details. And we pass to the next slide. To give you an idea of the step-by-step approach that we have followed in the PCP WISE project, we have gone through the preparatory phase. There has been the needs assessment identification, so understanding what are the problems and the specific requests from the public buyers and the end users. There has been a prior art analysis and IPR search conducted. This is described in our preliminary state-of-the-art analysis to understand what solutions are available in the market, what kind of patents are there, who are the owners of these patents. We look also into the analysis of the standard landscape to understand degrees of consensus in several domains. And now we are here in the Open Market Consultation. So we want that you challenge our findings, that you provide feedback on the questionnaire that we have developed and ask questions, as you are already doing now through the chat, and we will have several other events and activities for this interaction that will be very valuable in preparation of the actual tender. Following the Open Market Consultation, there will be also some value calculations and to decide on the trajectory to be followed, and also to fine-tune the tender documentation and also all the provisions, conditions, requirements that will be available in the tender documents. Next slide, please. Okay, so now that we're in the Open Market Consultation, we have set some rules, some objectives, as you will find in the Open Market Consultation that I've mentioned. And these objectives mainly are to present the public buyer needs to the market. So the market is informed in advance and prepare for a future tender. We would like to validate the findings of the state-of-the-art analysis. We have this preliminary state-of-the-art analysis shared with you in the Open Market Consultation document. And we need to understand also from your feedback from the market, from the users as well, the viability of the set of the technical and financial provisions as envisioned now. We want to obtain information on existing or to be developed technologies to complement the state-of-the-art analysis that we have performed. And it is also important for us to raise awareness of the industry and all the relevant stakeholders, including the users, to fine-tune the tender specifications. That is really relevant. We want to facilitate upfront the possibility to build up consortia based on the skills and the expertise that is required to participate in the PCP tender. Specifically, we like also to provide information on the innovation procurement procedures, which is the case of the PCP, that is the approach that we will follow, and tackle some topics related to intellectual property rights. I've mentioned before, and I underline the importance of this intellectual property rights distribution in the sense that technology providers will be able to exploit the results of the pre-commercial procurement. If we go to the next slide, and some also important aspect to mention is that this open market consultation is based on the Dutch law, that is the law of the lead procurer, that is het waterschapshuis. So applicable law, it's Dutch law for the open market consultation. So what is the OMC target? We're targeting all interested parties that could provide relevant information to the use cases in this market consultation. We need to understand what are the capabilities of the technology providers to satisfy the public buyers' needs, and to gather your input on the feasibility of the procurement plans. You will receive the slides where you can click on the links and find the OMC document and annexes, but these have been published on the website. Hans mentioned the expertise and the skills that are required from this multidisciplinary team that will be making up the consortia participating in the tender. And I would like to list them. You can see them here. So we're targeting technology providers and end users working in the fields of civil engineering and management, including upscaling, hydrology, including models, skills, services, crisis risk impact assessment, remote sensing value-added services, ICT for operational information production, upscaling, back front-end processing. Also solution architect, that is expert with skills to connect the different data available in silos. And knowledge on the legal and contracting aspects, specifically regarding European standards, artificial intelligence, IPR, data protection, for example. And what is important also to know about the open market consultation is that this is a voluntary, a non-binding process. You participate on a voluntary basis and provide feedback that is going to be valuable for the future tender, for the fine-tuning the specifications. Participating in the market consultation is not as such a condition to submit a tender. It does not lead to any rights or privileges, but being involved in these market consultations really provide value for us and also for you to understand better the public buyers' needs, and also what is possible, whether the market is ready, and if there are any information that we have missed in the assessment of the state of the art. This OMC is not meant to be a pre-qualification or selection process. We will get the information and be able to process and analyze it to get the best outcome when working on the tender. And if you give another click, I would like to mention and underline that all interested parties are invited to take part in the OMC. Parties from anywhere in the world that can provide their insights and valuable information. But of course, in the follow-up tender, there may be some conditions, and technology providers established in countries not eligible to participate in Horizon Europe innovation actions in any capacity cannot participate in an upcoming tender of the PCP procedure. But for now, the OMC, the open market consultation, is open to all interested parties. Once the tender is launched, you will see the specific conditions and requirements in that regard. Next slide, please. I've mentioned several times the open market consultation document, and I invite you to really look into the document, read it carefully, because it's describing all the rules, the objectives, described also the public buyers participating in this initiative. You will find that you can find the cases and the state of the art. I share with you the table of contents of this open market consultation document. So you can get an idea of this if you have not already read the document. At the end of the open market consultation activities, we will draft an open market consultation report. All the answers provided by the market parties will be summarized, anonymized, and this will be the conclusions will be published in the OMC report that will be made available widely, both in the PCP WISE website and the e-procurement platform, that is the Amiga platform. Okay, also all the questions that you are asking through the chats, through the different events will be also published, compiled in a document with questions and answers, the Q&A document, and this will be published so you can access it, and also any party which perhaps did not also participate in the open market consultation can also look into these documents and be aware of the activities and the questions that have been asked during this open market consultation. We go to the next slide. And in the next slide, we see some benefits from pre-commercial procurement, which may be relevant for you to know. For the contracting authorities, it is really important to understand if there are product solutions existing in the market that could tackle the unmet need. That's why we invite you to challenge our findings. Pre-commercial procurement being able to foster incentivize technology providers to innovate based on the demand of the public buyers tries to improve the quality and efficiency of public services, and is helping also to achieve this level of interoperability that can reduce the risk of vendor lock-in, because we're also trying that multiple suppliers provide different solutions that are comparable. And it's also helping to obtain better quality products in good prices to get best value for money, reducing the risk, and also having the licensed uses for the procurers. For the suppliers, this process is interesting because it is helping through funding to accelerate the process, to bring faster scientific results to the market, shortening the time for the innovative products to come into the market, and facilitating also the access of new players that could be startups and SMEs in the procurement market. We've seen from experience that pre-commercial procurement is also providing these let's say, incentive and these possibilities for company growth, also attracting private investment to the further exploitation of the results of the PCP. Very important is to keep in mind, and that's why I repeated, that the ownership of the intellectual property rights generated during the PCP are for those suppliers who generated. And for the society, the benefits are also important because we're trying to using in the best way the taxpayers' money to buy innovative products, to incentivize the innovation from the demand side, also tackling environmental and social challenges. And really this procedure is also having also other goals in terms of creating opportunities for the European industry and creating high added value jobs in Europe. We go to the next slide, already wrapping up. These are the activities within the umbrella of the open market consultation. We started the open market consultation with the publication of the prior information notice on the tenders electronic daily portal of for the European tenders. There is an open request for information questionnaire that has been published on the EU survey tool that is accessible for all of you. It was also posted in the chat. We want that you reply to this questionnaire. This will also be a requirement in case there are bilateral meetings with suppliers. There's also the Open Market Consultation document that is describing the whole market consultation activities and the rules. We have also an open module of the e-procurement platform where you can ask questions about the PCP WISE Open Market Consultation. And here is where we are today in the Info Day. This is the online event. And there are some other activities coming up. On the 30th of May is the deadline to submit your questions about PCP WISE OMC, about the Open Market Consultation through the module of the e-procurement platform. So keep in mind, keep all your questions and send them through the Amiga platform. We will publish the Q&A document. And on the 3rd of July, we will have the main event of the Open Market Consultation. This will be online. It will be a webinar. And in the 12th of June, we will have a hybrid event. That event will take place at Expandeo in Brussels. So you are welcome to join us both on site or online. And on the 13th of June, we will publish the answers to the questions that we have received throughout the activities of the PCP WISE Market Consultation. We'll publish the answers through e-procurement platform. By the 15th of June, you need to submit the request for information, the questionnaire through the EU survey tool. I would like to remind you that you can start to answer your questions on EU survey, and there's a function to save the questionnaire so that you can continue filling the information if you need to gather or collect other information, other data, or consult internally with your partners, your colleagues. And there is also the function on submitting the survey. So when you have the questions all completed, you can submit the questionnaire so we can receive it. On the 15th of July, we will publish the Open Market Consultation report that summarizes the findings, that provides the conclusions. This is an anonymized report. We're not sharing any sensitive information or data on the technology of the market players participating. And in this date, we will conclude with the OMC report, the period of the Open Market Consultation. Thank you so much, Joost, and thank you everybody for being here today, and we will see if there are any questions in the chat. Thank you.
Thank you, Ana Lucia. And now I ask Ana to elaborate a little bit more about the request for information already mentioned a few times by Ana Lucia and Hans already earlier. Ana.
Yes, thank you, Joost. Yes, I think Ana Lucia and Hans both already explained the request for information a lot, so I can be brief about this. Of course, since we are buying R&D services, a lot is still unknown for us. So therefore, we really need the input from the market to make sure that we are doing the right things and that we are asking the right questions during our tender. And therefore, we chose to launch this request for information through the EU survey platform. And we have, as you can see on the screen, different goals with this. So we want to validate our own findings. We want to collect your insights from the market, which we already saw some interesting questions and remarks raised during the chat this meeting. And with the ultimate goal to refine our tender documents so it fits the market capabilities and the market needs. And the request for information survey, it consists of 25 questions. And you can see the topics on the screen. So questions about the challenge we are facing, questions about the functional and technical requirements, the state-of-the-art analysis, the market needs and capabilities. And there's also room for your own suggestions and remarks. So please let us know if there's anything you have to add for us. So next slide, please. And here's some general information. I think Ana Lucia already explained it really well, that all the information provided will be treated confidentially. and we will summarize and anonymize all the findings, and we will publish this through our website in the OMC report. And of course, the deadline is on the 15th of June, end of the day, Central Eastern Time. So you still have enough time to fill it out. And as indicated in the screenshot on the screen, there's also a possibility to save a draft version. So if you don't have time to fill it out all at once, you can just do it in small parts. So next slide, please. Yes, and here's just some quick ways to ask us our questions. So through the e-procurement platform, through the PCP WISE community, and of course our PCP WISE website. There we already have frequently asked questions posted, and there's also a possibility for you to apply for our newsletter. So please do that if you want to be kept informed. And there's also an email address if you have any questions or remarks on the process. So that's it for now, I guess.
Thank you, Arnoud, and all the presenters for their contribution today. It's almost 12 o'clock, but I hope you have a little bit more time, and especially when you want to ask a question, because it helps you and it will help us. So if you have a question that you didn't put in the chat, then you can raise your virtual hand, and it's the first one is always the one who can the question that can be answered first, of course. And I hope I can see that. At this moment, I don't see any hand, but I can't imagine that you have you don't have questions.
Joost, there is a question from Niels.
Oh.
He's asking, what is the purpose of the OMC webinar on the 3rd of June?
Yes.
Answer this one.
Yeah.
I cannot. Yeah.
Yeah. So with the 3rd of June session, we really want to engage in more dialogue with the market parties. So this Info Day session has been sending a lot of information, and during the Open Market Consultation sessions, we really want to engage more in meaningful dialogue with you as a market, and to really gather a lot of information for us to refine our tender documents and to prepare better for the tender. So that's in short the goal for the session. And we will also have an agenda of the meeting through the registration page, I believe. So, and if not, we will make sure to include it in there, so you can decide if you want to join, but we would love to see you there.
Okay, thank you, Arnoud, for your contribution. Any other question? No. Arnoud showed already the email address, which is on your screen now, where you can ask your questions, and of course we will try to answer them as quickly as possible, and take into account that those questions are going to make public, but of course anonymously. And I want, Ellen has a question. Ellen, yeah. Please.
Can you hear me well?
Yeah.
Good. Yeah, no, I just a slight confusion between the community platform and the request for information, i.e. what I should put where. It looks like the community platform is more for exchanges and more basic summary information, and the request for information, I'm talking about the company that I work for. So in reality, most of what I put in there will not be my profile, but it would be the profile of the company that I work for as a supplier. Now I'm just curious to know what I should put in the the request for information. That is more for more detailed information, and the community platform is for more, let's say, sketchy or basic information, summary information. Is that correct?
Melissa.
Shall I?
Okay. 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 You.
Yeah, so the community platform is actually formed to help you as suppliers to also find each other and to interact with buyers if you have more specific questions. And the request for information really is for the in-depth information that we need from you to understand your insights better. But the community platform is really to help form consortia, for example, or to connect with people from the PCP WISE consortium or to other interested parties. And as Hans already mentioned, we expect a lot of different competences from each supplier. So in that case, we can imagine that not everyone ticks all the boxes and that they might need to work together with other companies as well. So that's why we have the community platform.
Thank you.
Okay. There is room for another question. No, if there isn't any, please join us then on the 3rd of June and on the 12th of June. If you have questions later on, please put them, ask that via the email address, and we will answer them as quickly as possible. Thank you all for your contribution, for your attendance, and I hope it made you eager to form a consortium and to make and offer us a bid. Thank you very much.
Thank you very much and have a great day.
Thank you all.
Goodbye.